Welcome to the debate. This show is part of Digi-Tech Debates, a segment of Project Plain Talk. And, think about when you build a bridge. You test the load-bearing capacity of the steel well before you ever let a single car drive across it.
Right, of course.
You have gauges, you have stress tests, you have a very clear numerical understanding of exactly when that steel will buckle. The metrics are just absolute.
Yeah, it's a known science.
Exactly. But today, we are looking at a space where those absolute metrics seem to be, vanishing right before our eyes. We're diving into the 2026 Artificial Intelligence Index Report, which was just published by the Stanford University Human-Centered Artificial Intelligence Institute, or HAI.
And the data in this year's report is, honestly, it's striking, especially regarding how we even measure what these systems can do anymore. I mean, to use your bridge analogy, the gauges we use to test the steel are starting to spin wildly out of control.
They really are. So the central question we are tackling today is this. As frontier AI models become nearly indistinguishable from one another, and as the traditional benchmarks we use to test them completely saturate, what does this actually mean?
Right. Is it a good thing or a bad thing?
Exactly. Does this represent a healthy maturation and a natural commoditization of the technology? Or is it a dangerous breakdown in our ability to evaluate and understand the AI systems that are, weaving themselves into our daily lives?
It's a massive question.
It is. And my position is that the saturation of these benchmarks and the convergence of model capabilities, they're clear signs of successful, widespread technological integration into the real economy.
And I view the exact same data as a severe warning. To me, it shows that artificial intelligence is scaling significantly faster than our tools for transparency and accountability can adapt.
Okay, let me lay out why I see this 2026 Stanford HAI report as a largely positive indicator of technological maturity. Because for the last decade, AI has been treated as a laboratory science. It was an academic pursuit where developers were constantly trying to inch past each other on standardized tests designed to measure reading comprehension, logic, or coding ability.
Right, the traditional leaderboards.
Exactly. But what this report shows is that we are successfully transitioning from the lab to a ubiquitous, standardized utility. I mean, the report explicitly notes that open-weight models are more competitive than ever, and that the leading frontier models are nearly indistinguishable from one another.
Which is exactly what concerns me.
But see, some people might view that lack of differentiation as a problem. I view it as stabilization. When you buy a light bulb, you don't really care about the proprietary variations in the tungsten filament, right?
Sure.
You just expect it to turn on and illuminate the room. AI is reaching that baseline. Furthermore, the report highlights that AI integration is moving aggressively into foundational economic sectors, things like waste management and administrative support services.
Yeah, the enterprise adoption is definitely accelerating.
It's crucial. And I'd argue the reason our technical benchmarks are saturating, the reason we don't have clear academic differentiation anymore, is simply because the technology has graduated. It is now proving its value in practical, gritty economic applications rather than on, sterile academic tests.
We're looking at a technology that has finally grown up.
Well, that is a very comforting narrative. But frankly, when you look closely at the methodology and the actual warnings embedded in the Stanford HAI data, the picture is fundamentally one of a crisis in evaluation.
A crisis?
Yes. The report is not describing a technology that is comfortably matured. It's describing a runaway train. Let's look at what the co-chairs of the report explicitly stated. They note that the field is scaling faster than the systems around it can adapt.
Right.
And that is not a description of a stable utility. When the report says leading models are nearly indistinguishable, that is not a success story about a stable baseline. It is a symptom of a deep systemic failure.
How is it a failure if they're all performing exceptionally well?
Because it specifically means that the tools used to evaluate these systems are struggling to stay relevant. If all the top models are suddenly acing every test we throw at them, it doesn't mean they are perfectly reliable or, equally capable. It means our yardsticks are fundamentally broken.
I see what you're saying, but
We are flying blind. And to make matters worse, the report points out the critical danger that frontier labs are disclosing less. and that independent testing does not always confirm what the developers themselves are reporting. We have a technology scaling into critical infrastructure while the fundamental mechanisms of scientific verification are just falling apart.
Okay, let's dig into that idea of broken yardsticks. Because if you're listening to this and wondering why a broken academic test matters as long as the AI, writes your corporate emails perfectly, we have to look at what benchmark saturation actually means.
Right?
For years, we measured AI with these specific tests. Now, the models score 99% across the board. You're saying the yardstick is broken. But isn't it more accurate to say the engine has just passed the laboratory stress test?
I wouldn't use the word pass.
Well, if I'm evaluating an engine, eventually I stop looking at laboratory RPMs in a controlled environment. I just care if it successfully runs the garbage truck on a cold Tuesday morning in Chicago.
Sure, practical utility matters.
Right. So if real-world utility is working and the models are converging on high performance, why obsess over saturated benchmarks? Hasn't the base technology just reached a point of maturity where real-world utility is the only benchmark that matters?
Because your engine analogy skips over the mechanism of how these models are acing the tests in the first place.
How so?
In the automotive world, the garbage truck engine has standardized, transparent safety ratings. You know the exact structural failure modes before it ever hits the streets of Chicago, because it was evaluated against the laws of physics. With AI, these benchmarks are saturating largely because of data contamination.
Wait, meaning like the actual test questions are bleeding into the data the models are trained on?
Precisely, yeah. These models learn by scraping vast swaths of the internet to build their neural networks. And the standardized tests we use to evaluate them, also hosted on the internet.
Ah.
So they aren't necessarily reasoning through the benchmark. They've effectively memorized the answer key. When the Stanford report says the tools used to evaluate them are struggling to stay relevant, it's pointing to the fact that we can no longer tell the difference between true cognitive capability and just sophisticated pattern replication.
Okay, but even if...
We aren't moving past lab tests because we have better real-world tests. We're moving past them because the models outgrew the boundaries of the test environment. We have no idea what the unique failure modes of these indistinguishable models are when they are deployed at scale.
Well, let me push back on that a bit. Even if we assume some data contamination, right? The convergence of capabilities, the fact that the top models from entirely different companies are nearly indistinguishable, that suggests a structural reliability.
I disagree.
But hear me out. If I prompt 3 different frontier models to draft a complex logistics plan for a waste management fleet, and they all produce highly coherent, nearly identical, optimized routes, the lack of distinction isn't a failure of evaluation. It's proof that the architecture of modern AI has fundamentally solved that specific problem space.
Or it's proof that they are all trained on the exact same corpus of human data, and therefore share the exact same blind spots.
If they are indistinguishable on standard tasks, we only know how they behave in the dead center of the bell curve. What happens when there's an unprecedented supply chain disruption in your waste management scenario?
What happens in an edge case?
Well, they adapt based on we are completely blind to the tails of that distribution curve. And the tails are where catastrophic systemic logic failures happen. This loss of diagnostic resolution is dangerous. I mean, we are trying to measure the speed of a supersonic jet using a stopwatch designed for a high school track meet. We just don't have the instruments to capture what is actually happening.
Okay, sure. I'll concede we need better instruments. The subject has definitely outgrown the frame. But let's look at why that frame is shifting, specifically regarding your point about frontier labs disclosing less.
Yes, a huge red flag. You framed it as developers actively hiding things. I look at it as a fundamental economic shift. We're moving away from an academic prestige economy where every lab published meticulously detailed white papers explaining every parameter of every weight and every piece of training data into a capitalist product economy.
But that transition shouldn't cost us transparency.
But it has to, logically. The report specifically calls out sectors like administrative support services and waste management. These are massive, globally significant industries. As AI scales into these spaces, we are dealing with multi-billion-dollar economic efficiencies. Of course, frontier labs are disclosing less.
So they prioritize profit over safety?
they are protecting highly valuable trade secrets in a fiercely competitive market. That opacity, it's just the natural evolution of any technology, transitioning from an academic sandbox to the bedrock of the global economy.
You can't claim that the technology is mature enough to be integrated into the bedrock of the economy while simultaneously accepting that the bedrock is made of a proprietary material that nobody is allowed to inspect.
I mean, we inspect the outputs.
Let's look closely at administrative support services, which the report highlights. We aren't just talking about a digital assistant scheduling meetings. Administrative support encompasses legal document processing, financial compliance routing, and massive logistical networks.
Absolutely high stakes.
Exactly. So if the models powering these services have hidden structural vulnerabilities, or if they confidently hallucinate incorrect regulatory compliance data, how can any business or government entity trust them? And here is the kicker from the report. Independent testing does not always confirm what developers report.
I understand the frustration with limited disclosure. I really do. But isn't that exactly why the market relies on empirical results? If a frontier model deployed in administrative support routinely hallucinates financial data, the company using it will realize the error and pivot to a competitor.
Oh, so we just wait for the disaster?
No, the market itself acts as a verification mechanism. The economic incentives perfectly align with reliability.
The market is entirely reactive. Relying on the market to catch AI failures means you are waiting for the failure to cause real-world damage. You're waiting for financial loss, logistical collapse, security breaches, all before you correct it.
Well, companies do their own internal testing.
But that is exactly why the scientific method relies on independent, preventive evaluation. When developers disclose less, they aren't just hiding trade secrets to protect their bottom line. They are hiding their failure rates, their security vulnerabilities, and their structural limits. If independent testers cannot look under the hood and confirm the performance metrics a developer claims, then those developer reports are no longer scientific data.
What are they then?
They are marketing materials. We are allowing companies to integrate hyper-complex logic engines into critical infrastructure based on an honor system.
Okay, but we aren't relying purely on an honor system because the report highlights a massive counterbalance, the open weight ecosystem.
Right, the open models.
Yeah, open weight models where the underlying architecture and parameters are publicly available for anyone to download, tinker with, and run locally, they are more competitive than ever. This is a crucial piece of the puzzle. We have thousands of independent researchers constantly prodding and deploying these models in specific, localized ways.
They do great work, yes.
So if a proprietary closed lab makes a specific claim about their model's capability, the open weight community can test similar architectural concepts to see if the math holds up. The open models provide a baseline transparency that forces the top labs to deliver on their promises, even if they don't hand over their proprietary code.
Well, open weight models are a fantastic resource for understanding baseline architecture, absolutely. But the Stanford report clearly distinguishes between those open weight models and the leading frontier models.
They're getting closer, though.
The frontier is where the new emergent capabilities lie. And that is precisely where the transparency is shrinking. It's great that we have a robust, open understanding of yesterday's technology, but the warning from the co-chairs is about the technology being scaled today and tomorrow.
I see what you're saying.
If we rely on open weight models to help us understand the proprietary frontier, we will always be one step behind, trying to deduce the dangers of a new system by looking at an older, slightly less capable one.
I don't think it's just yesterday's technology anymore, though. The fact that open weight models are catching up to the point of being, quote, more competitive than ever suggests that the technological moat around those frontier labs is rapidly shrinking. The secrets are getting out.
Getting out how?
Not through corporate espionage, but through the natural democratization of algorithmic science. As compute power becomes more efficient and basic architectural breakthroughs become widely understood, the baseline of what is open just naturally rises. The indistinguishability of models isn't just happening at the top tier among the closed labs. It's happening across the board. This points toward a future where high-level AI is a common, accessible commodity.
But the democratization of capability does not automatically equal the democratization of evaluation. If anything, highly competitive open-weight models proliferating without adequate evaluation tools amplifies the risk.
Amplifies it? How?
Because now you have incredibly powerful systems in the hands of millions of independent actors, and we still have the core problem. The benchmarks are saturated. We do not have the metrics to accurately gauge the security flaws or the structural limits of these ubiquitous systems. Whether a model is a closed black box from a frontier lab or a widely available open-weight system, if the tools used to evaluate it are struggling to stay relevant, we are expanding our surface area of risk exponentially.
All right, let's look closely at that adaptation gap. Because the co-chairs use a very specific phrase that we keep circling. They say AI reveals a field that is, quote, scaling faster than the systems around it can adapt.
Right.
I interpret systems broadly as societal and economic infrastructure. Think about corporate IT structures, legacy logistics networks, our bureaucratic frameworks. These are the systems struggling to adapt to the sheer capability and speed of modern AI.
I think that's
The AI itself is highly functional. It's the rest of the world that is playing catch-up to integrate these highly capable tools.
a very generous interpretation of the text, but the context of the co-chair's message anchors it directly to the data they are presenting. And the data they present immediately after that statement is about evaluation.
Okay, fair.
They explicitly point out that as models converge, the tools used to evaluate them lose relevance. When they talk about systems failing to adapt, they are primarily talking about the fundamental guardrails of responsible AI, our testing frameworks, our auditing processes, our independent verification protocols.
But you can't cleanly separate the evaluation tools from the deployment environment, right? If an AI is optimizing a waste management grid, the ultimate evaluation tool is whether the physical streets are clean and the trucks used 20% less fuel. The real-world application becomes the dynamic benchmark.
Measuring the fuel saved by a garbage truck is easy. Measuring whether the complex neural network that routed that truck is susceptible to adversarial attacks where, a bad actor intentionally feeds it confusing data to break its logic, that is incredibly difficult.
True.
And that requires sophisticated, independent evaluation tools that are external to the deployment environment. If independent testers cannot verify the safety and performance boundaries before the truck hits the road, the systems that are failing to adapt are the very safety nets designed to keep the public secure. This scaling is happening in a vacuum of scientific accountability.
Listen, I hear your concern about accountability, but I think you are underestimating the capacity of the engineering community to develop new paradigms of measurement. Yes, the old static benchmarks, the multiple choice tests, the basic coding challenges, they're dead.
Very dead.
The models ace them, or, memorize them as you pointed out. But that doesn't mean we are permanently blind. It means we're in a transitional phase. We are moving from static, retrospective benchmarks to dynamic behavioral evaluations. The fact that the 2026 Stanford HAI report is calling this out is actually a sign of health.
A sign of health.
Yes, because it shows that the independent academic community is highly aware of the shift and is actively pivoting to address it.
Being aware of a problem is not the same as having a solution. The report clearly states that independent testing does not always confirm what developers report. That implies that even when we do try to apply new or existing independent tests, there's a fundamental disconnect between the labs building the tech and society trying to understand it.
But they'll figure it out.
How? When frontier labs disclose less, they actively hinder the academic community's ability to develop those new, dynamic behavioral evaluations you're talking about. You cannot build a rigorous stress test for a system if the creator of the system refuses to let you see the schematics. We are moving into a regime where a handful of corporate entities hold asymmetric knowledge about the most powerful technologies on Earth.
Well, we are definitely looking at the exact same data points from the 2026 Stanford HA report and coming away with two vastly different paradigms. To summarize my perspective, I look at this AI index report and I see the inevitable, messy, but ultimately successful transition of a technology out of the laboratory and into the real world.
Right.
The convergence of models, the saturation of academic benchmarks, and the rise of highly competitive open-weight systems all signal a stabilizing technology. The fact that it's finding a permanent home in grounded economic sectors like waste management and administrative support,
Well, that proves its practical utility. Yes, evaluation tools need to evolve, but the current state of affairs is a testament to the technology's robust maturity, not its failure.
And to summarize my view, I look at the Stanford AI data, and I see a blinking warning light. The report is explicit. Leading models are indistinguishable, independent testing is failing to verify developer claims, and the labs building the most powerful systems on Earth are hiding more and more of their work. When the tools we use to evaluate a technology lose their relevance and the creators of that technology operate in the dark, rapid scaling is a massive vulnerability, not a victory. The co-chair said it best: the field is scaling faster than our systems can adapt, and that adaptation gap is where real systemic failures will occur.
Well, despite our deep disagreement on the trajectory, I think we both find absolute convergence on one critical insight drawn directly from the text. The current tools used to evaluate AI are undeniably struggling to stay relevant. The entire paradigm of how we measure, stress test, and understand artificial intelligence has to change. I mean, the era of multiple choice testing is over.
Oh, we are in complete agreement there. The industry and the academic community must prioritize the invention of new, dynamic evaluation frameworks that can actually penetrate the complexity of these models, whether the labs want to hand over the blueprints or not.
Definitely. The Stanford HII 2026 AI Index report is incredibly dense, and there's just so much more nuance in the full document regarding public opinion, policy, and scientific breakthroughs that we encourage our listeners to explore for themselves. We aren't here to declare a winner, but rather to give you the dual lenses needed to examine this data. We are trying to measure the speed of a jet with a stopwatch designed for a high school track meet. It's up to you to decide if that means the jet is flying perfectly or if we're on a collision course we just can't track yet.
Until we build a better radar, we won't really know.
Thank you for joining us for this segment of Project Plain Talk. Keep questioning the data.